This question says determine whether WX and YZ are parallel, perpendicular, or neither. So what we need to do is find out what the slope of the lines are. So we need to find an equation for this line. Let me change the color of this. We need to find the equation. Whoops, that was a negative there. The equation for that line. So I'll do that in green. And then we need to find the equation of the red line. And all we have to look at is the slopes, basically. Well, we also, I guess, technically have to make sure they're not the same line. But we just have to look at the slopes. And if the slopes are equal to each other, then the two lines are either the same line or they're parallel. If the slopes are negative or opposite reciprocals of each other, then they're perpendicular. And if neither of those is true, then they're just intersecting lines, which means neither perpendicular or parallel. So remember how you find slope? You take the rise, which is the y's, over the run, which is the x's. So we'll call this 0.2 and we'll call this 0.1 for my green line. So it's -8 minus a -2. See how I took those y's out of there? Over 3 minus -3, which equals, remember that becomes a positive. So -8 plus 2 is -6, and that's +6. So the slope of that is -1. Got it? Let's do the red one now. Same deal. We'll call this 0.2 and we'll call this 0.1. The slope of that red line is equal to the y's, -1 minus a -7. Notice how I'm being very careful with my signs. All over 4 minus 5. And that equals, this becomes plus, that equals +6 over -1, which equals -6. So are they parallel, perpendicular, or neither? Remember, if the slopes are the same thing, they're parallel, or they're the same line. If the slopes are negative reciprocals, they're perpendicular. And if the slopes are neither one of those, then they're neither parallel nor perpendicular, meaning they're just intersecting lines. And that's the case that we have here.